Here we have combination of lenses and mirrors. Okay, I have two lenses here, one lens and one mirror here. I have to locate final image. Locate final image. Okay, so I have to find its distance. Distance from where? From which position? Okay, so let's in both cases let's find the distance from this convex lens. Okay, in both cases. The next problem, final image coincides with object. Object is kept here. Finally, final image coincides. Okay, why it will coincide? It is because this mirror is kept here. Light is going to be reflected, and that's how it is coinciding. Okay, I have to find, in each case I have to find a certain value. First and second case, I have to find this distance. Okay, what is separation between lens and mirror? First two cases. In third and fourth case, you will see I have to find here the object distance. At what distance I should keep my object such that the final image coincides with the image. Final image coincides with the object. Radius of this surface is given, refractive index of this medium. Okay, so this is my lens here. One surface is silvered. One surface is silvered. In both cases, at what distance I should keep my object to get an image, final image coinciding with the object itself. Okay, let's start with this first problem. Okay, now different distances are given. The separation between two lenses, lens and mirror, is equal to d. Different values of d are given. In both. For each d value, I have to locate the final image. Okay, what will you do? We have done such problems. Okay, in case of two mirrors, let's say. So what we do is, we forget about the second lens. Forget about the second object. You just look at the first object, first image. First you locate the first image. Okay, and then you figure out what will happen if I bring in the next one when I introduce the second lens or mirror, whatever. So first let's focus on the first image. Okay, so in this first problem here, first image. Okay, how do I find out? 1 over v is equal to 1 over f plus 1 over v. Okay, 1 over v is 1 over f plus 1 over v. It's a converging lens. So focal length will be positive. So plus 20. What it is? Plus 20. Okay, and then plus 1 over. What it is? This is 25. So minus 25. Okay, it is minus 25. So I can take it as 100 here. 100. So this becomes 5 minus 4 plus 100. Okay. So what is first image? V1 is equal to plus 100 centimeter. If I do not have this lens, the second lens, I am going to get my first image here, 100 centimeter. In all the cases, no matter what is the separation. Okay. Now, let's start with this. The first problem itself. This distance is 120 centimeter. 120. Let's draw this ray diagram first. Ray diagram. Okay. We are going to get the second image. Very easily. It's very important to be comfortable, very, very comfortable with ray diagram. Okay. You cannot ignore it. You start ignoring it, you are inviting trouble. Okay. Understand? This is my object here. This is my object. Okay. The first image is at 100 centimeter. 100 here. My first image is somewhere here. This is my first image at 100. This is I1. That's how the first image forms. Okay, understood? Now, if I do not have this, that is the first and last image. And remember, the light rays are converging here, but they do not stop. They continue moving. Light rays never stop. They continue moving. Refraction, reflection, whatever it is. Now, the second lens is at a distance of 120 centimeter. That means after the image is formed. Okay, this whole thing from here to here is 100 centimeter, 100 centimeter. I have one other lens here. Now this distance is 20 centimeter. It is given because it is 120. Okay. Now the light rays will continue. Light rays will continue, and they will hit the second lens. Now for this lens, this becomes an object. Okay. What is focal length? Focal length is 30 centimeter. So for the second lens, these light rays, incident light rays, are coming from this point here. It becomes an object, a real object. Where is the image? Okay. Second image. Second image, 1 over V2 is 1 over F plus 1 over U. Okay. This is 1 over, okay, focal length. It's a diverging lens. Focal length is going to be negative. Okay, so minus 30 plus 1 over minus 20. Object distance is negative in this case. Okay. If I look at the sign convention, this is the sign convention. This is the sign convention. Okay. Now, so this will be equal to 60 here. So minus 2 and minus 3. V2 is minus 12 centimeter. Minus 12. That means the light rays are going to diverge from here. And after the diverge, they appear to be coming from this point here. This is how the light rays are going to diverge. Now this distance from here to here, this distance becomes 12 centimeters. 12 centimeters. So what is my answer? I have to locate it. Okay. So this whole thing is 120 minus 12. 120 minus 12. 108 centimeter from convex lens. Okay, this is the answer. Now what is the nature of image? The first image is real image. This is the second image. Second image will be virtual. So if I am standing here, my object is here. Okay. So when I see from here, okay, the object will appear to be here. The actual distance of object. The actual distance of object is 120 and plus here. Here it is 25 centimeter. The actual distance, you see, try to understand this thing. Very, very important. If I stand here, from this point here, the actual object is at 145 centimeter. But when I look at from here, the object appears to be here. If I am looking from here and this whole thing is closed in a box. Okay? I have no idea, absolutely no idea. You will never know whether there is only one lens or two lenses or how many lenses there are behind this lens. If the lenses are perfectly clear, perfectly clean, you cannot figure out because what you are going to receive is only these two light rays. That's it. Okay. You can never figure out where the actual object is or if there is an actual object or not. This thing becomes an object for you. The object appears to be here at 12 centimeter. Okay, so the object is at this distance. It is brought here. The object is brought here at this point. That's how we design microscopes, telescopes. We will see. We will see when we do those instruments. Okay, so this is for the first case. Now, what about 100 centimeter? Now, the meaning of 100 centimeter is that before the image is formed, okay, I am intercepting these light rays. I do not allow the light rays to converge. Okay, I do not allow the light rays to converge. Okay, so my lens is not here. Okay, so actually, what I am doing is I am intercepting these light rays. Intercepting it. Okay, like this is my lens here. It is kept at a distance of 100 centimeter. 100 centimeter. Okay, so this is 100. Okay, no, 1 second. 100 centimeter. The image is formed at 100. The first image is formed at 100 and my lens is kept right at that position, right there. This is my first image, I1. My lens is right here. This distance is 100. Okay, so all these light rays will be passing through the optical center. Okay, so they will come out without any deviation, So here itself will be my image. Okay, I don't have to solve it. I don't really need to solve it. Okay, I don't really have to solve it. This becomes the same point. I will get an image at the same point because all these light rays are actually passing through the optical center of this lens also. The distance is 120. Okay, do you understand this? So I will get my image then and there, right there. Okay, so I will see my object to be here if I am looking from this side. Now, third case, 80 centimeter. 80 centimeter, that means I do not allow the light rays to converge. Before they converge, I am intercepting them. So they are trying to converge here. They are trying to converge here at a distance of 100 centimeter. 100 centimeter. This is 100. Okay. But before they converge, okay, I intercept these light rays like this here. Okay. This distance is 80 centimeter. 80 centimeter. Then this will become 20 centimeter. That means light rays cannot really reach here. Okay. So this is the incident light. They are trying to go there, but they cannot go there because in between I have this lens. I am intercepting the light rays. Now for this lens, this becomes an object. What type of object? A virtual object. These incident rays, the incident rays on this lens are corresponding to this object here. So for this lens, the object is here. Okay, a virtual object. A virtual object. This is a virtual object. The first image acts like a virtual object for the second lens. Now these light rays will diverge. After diverging, they can make real image, they can make virtual image, depending on this distance. Okay, so this is 1 over minus 30. 1 over minus 30, focal length is minus 30 centimeter, plus, now this u becomes positive, it is plus 20, it's plus 20, this becomes 60 minus 2 plus 3, v2, it becomes plus 60 centimeter, plus 60, that means these light rays will diverge, and after diverging, they will diverge a little bit, and they are actually meeting here. That's where I am going to see my final image. Okay, think about it. I am getting a real image. I am getting a real image from a diverging lens. What will be this distance from here to here? It is going to be 60 centimeter. 60. So what is my answer? 80 here, 80 plus 60, 140. 140. Okay. Now, you know what? If I change this distance, instead of keeping it 80, what if I make it 70 centimeter? 70 centimeter. Can you find out the answer? 70 centimeter. Okay. That means this is 70 centimeter. 70 centimeter. This focal length is 30 centimeter. Okay. What is going to be the answer? What is going to be the answer? This is 70 centimeter. The light rays are trying to converge here, but they cannot converge. This is I1. And this point where the image is, this lens is trying to form an image is coincidentally also the focus of this lens. The light rays are trying to go towards that point here. Focus, that is the focus of this. This is equal to 30 centimeter. 30 centimeter is equal to focal length of this lens. what will happen? They will become parallel. They will become parallel. Now if I look from here, the object appears to be at a very large distance, at infinity. Okay, when I trace back these lines, it seems to be coming from infinity. Image will be at infinity. Okay? Now, let's look at the second problem. Okay, so this we did. Same way we have to do the other problems also. You will find many problems in problem sheet. Okay, here 30, 40. Let's first find the first image. 1 over V1 is 1 over F plus 1 over U. So 1 over focal length, converging lens, 30 centimeters, is plus 30 here. Okay, plus 1 over, this is minus 40. Minus 40. This is going to be equal to 120 here. So minus 4 plus 4 minus 3. Okay, so V1 is going to be plus 120 centimeter. This is the first image by the first system here, lens. Okay, understood? Now, this is 125. So let's first draw this first image. Let's draw the first image. Ray diagram, okay? Ray diagram of the first image. Okay, this is my, okay, so my object is here. This is my object. This distance is 40 centimeter. Okay, the image is formed at 120. This is 120. Okay, let's say that this is 120. That's where the image forms. This image is I1. Okay, this distance is 120 centimeter. The light rays do not stop. If I do not have this, I get only one image. That's it, final. If I have this plane mirror, this is 125 centimeter. 125. That means my mirror is here. This distance is 5 centimeter. 125. So that becomes 5. Now the light rays do not stop. They hit the mirror like this. They hit it. Then they get reflected. After they hit it, they get reflected. Okay? Image will form at what distance? Same distance behind the mirror. It's a plane mirror. Same distance behind it. They seem to be coming from here. Okay, what will be this distance? This is also 5 centimeter. And after reflection, they are not going to stop. Okay, they are going to move in this direction. And then they will reach here and hit the lens. This is second image. This is second image. I have to locate the final image. Okay, the light rays will hit this lens again. They are going to hit this lens again. Okay. Now for this lens, the rays appear to be coming from this point. First image from lens, it becomes object for mirror. It makes one image. Now this image from this mirror, it becomes an object for this lens. What is the object distance? Object distance, it is 130 centimeter. It is 130 centimeter, okay? What is the focal length? Focal length is 30 centimeter, okay? This focal length here is 30 centimeter. So this is my second image that we found very easily because it was a plane mirror. Now the third image will form. Third image. Okay, so I have my object here. Light rays are going towards left. Light rays are going towards left. Okay, so this becomes my sign convention. This is positive here and this is negative here. Now to the left it becomes positive. Okay, now 1 over V3 is 1 over F plus 1 over U. You see, focal length is always positive. Remember this. This is a very confusing thing, especially in such type of problems when several successive refractions take place. focal length of a converging lens is always positive. Converging lens, no matter where the object is kept, no matter how the light is coming. This is something you have to remember, keep in mind. Focal length, converging lens, always positive. Diverging, always negative. Now, this becomes plus 30 here, plus 30 here, plus 1 over minus 130. Minus 130, okay. So this will be something like this. This will be 120, 390 here. So this becomes 13 minus 3. Okay, I think I'm doing it all right. I'm getting a right and fine answer, okay. This V3 is going to be equal to plus 39 centimeter. Plus 39, this is 40. That means these light rays after this is plus. What is the meaning of plus? This is plus here. Okay, so I'm going to get my image, the final image is here. After this, there is no further reflection or refraction. After this point, there is no further reflection or refraction. So this is the final image. This image is the final image. I3. This distance will be 39 centimeter from the lens. Did you get the same answer? Okay. Now, apply, okay, the next one, 80 centimeter. Okay, one more. Next one was 80. This D was 80. Second part. Let's do the second part also. 80 centimeter. Let's see how many images we get. Okay. So this is my lens. Object. This is my first image here. 120. This whole thing is 120 centimeters. Okay. Now, in between I am keeping my mirror here. My mirror is here. Okay, what was this distance? This was 40 centimeters. Try to understand. Okay. It's going to be very interesting. We do not require much calculation. We do not really require much calculation. Whatever calculation is required, we have done that already. Now this is 80. This is 80 centimeter. So this is 40 centimeter. Now the light rays cannot reach here. Okay. They are going to be reflected. Now for this mirror, this becomes a virtual object at what distance? 40 centimeter. Virtual object at 40 centimeter behind the mirror. Image will be same distance, 40 centimeter in front of mirror. Okay. So I am going to get it something like this. That's where the light rays will be reflected. Okay. So this is my second image. It is going to be a real image. A real image from plane mirror. Real image from plane mirror. Okay. The light is started from here. Okay. Now what will be this distance? This distance is 40 centimeters. Now see this. Object at 40, image at 120. Here also I have exactly same thing. Now this becomes, now the light rays don't stop here. They continue moving and they hit the lens like this. Here again I have this object distance is 40. Where will be image? At same distance, 120 on the other side. Okay. So I am going to get my image here. 120. Because the light rays are going to converge something here like this. Okay. This is going to be my third and final image. This distance is going to be 120 centimeters. Okay. Do you see this? Do you understand this diagram? Understand it pretty well. Okay. If you understood all of this, you know how to solve these problems. Okay, it should not be difficult. should not be difficult at all. Okay. Ray diagrams very important. Do not ignore the ray diagrams. If you ignore it, you see the light is out from, you see, chase the light, that's it. Ray diagram is all about chasing the light rays. It starts from here, it gets reflected, then refracted, it comes like here. Okay, this light gets reflected here, goes to the lens again, then finally it reaches here. After this point, there is no further reflection or refraction. After this point, there is no further reflection or refraction. Okay, that's it. I will get final image here. Okay, next problem. Do it carefully. Final image coincides with object. Final image coincides with object. Find distance between this. What should be distance here? Lens, mirror. Final image coinciding with object. If I have a mirror, that means the light must retrace. Light must retrace, okay? This is the condition for retrace. Remember this. Retrace. All the conditions are retrace. 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 Standard condition for retrace. Other than this, there is a retrace like. This is the proper retrace. Now there is one retrace like. Retrace like condition. Retrace like condition is like this. Any normal reflection from plane wave. In this case, this is a retrace like. Okay, I can do it like this. A retrace like condition. Here also, a retrace like condition. We will see, we will discuss what do we mean by this. Note down. Final image coinciding with object. That means on the mirror, rays should be incident in either of these cases. It is going to retrace. It is going to retrace. Let's see how. Okay. Keep these diagrams in mind. Okay. You draw it separately. Pause the video, draw it separately. It's going to be very helpful. Very helpful. Okay. You will realize this potential. Okay. First thing, let's draw the first image. Okay, first image. First image, okay? Now, 1 over V is 1 over F plus 1 over U. Converging lens positive, 20 here, plus 1 over minus 30, okay? Minus 30. So in both cases, we are going to use the same result, okay? Same result. So let me, it will be better if I write it here. Both cases, same lens, same object distance. So first image, okay? I'm sure you must have got it already. 1 over F plus 1 over U, 1 over plus 30, plus, okay, not plus 30, but plus 20, plus minus 30 here. Okay, object distance. This is going to be equal to plus 1 over 60. Okay, so V, this V1, first image is plus 60 centimeter. Plus 60 centimeter. Okay, now let's draw the ray diagram first. Ray diagram. my object here. Now this is going to be the image. This is going to be the image. Okay. You understand this? You understand this? Okay. Now, first image. I want my image to coincide with object using this plane mirror. Using this plane mirror. Okay. Now, from plane mirror, okay, it becomes very obvious to understand if I do not draw this ray diagram. Okay, I am drawing just one. I am drawing just one ray. This is I1. I1 here. I1. One light ray here. I am taking these two light rays, that's it. One light ray here, other light ray here. Okay. Now, I want to retrace, but it cannot retrace. From a plane mirror, it can retrace only in this manner. Okay. But if I create a situation like this, okay, if I create a situation like this, then also it is going to be retrace like, not retrace but retrace like. It's like this. If I keep my plane mirror here, right here, where the image forms, right here, where the image forms. Okay. Whatever is the angle here, it is going to be reflected at the same angle. And this light is going to retrace. And this light is going to be reflected in this direction. Now, for this lens, this is object, this is image. Now, if I keep object here, I will get my image here. It's like this. What should be answer? Wherever the image forms, right at that point, I should keep my plane mirror. So finally the light is going to be reflected and then it will reach back to the object. Final image coincides with object. Now, in second case, I can do the same thing with second case also. I can do exactly same case, exactly same thing. Exactly same thing with second also here. That's it. That's it. Okay? That's what it is. Now, in second case, in this case, I have one other possibility. What is the other possibility? It's a concave mirror. Okay? So I can let this light ray pass through its center. This is the center. In that case, also it is going to retrace. Okay. So this is one answer. One answer for this will be same as this answer here. What it is? It is 60 centimeter. One answer is 60. Okay. I can also keep my mirror in a different way. I can also keep it here at a distance here, such that for this mirror, this light seems to be coming from its center. Okay? This light seems to be coming from the center. So this is the first image. I arrange my mirror such that this point becomes the center of this mirror. Okay? So this thing is going to be equal to, this is focal length is 30. This radius is going to be equal to 60 centimeter. This is 60. This also is 60. So I have two answers. So answer for this is 60 centimeter and 120 centimeter. Answer for this 60 centimeter. Okay. Now what if I have a convex mirror like this? A convex mirror. So I can keep it here. This is the first possibility. Okay. And I can also keep it here, such that this point becomes center for this. Okay, so the light will be reflected, retraced from this point itself. Then I will get my final image here. Okay. You will find problems based on this also in problem sheet. Okay. Now the next two one face is silver, but that's fine. One face is silver. Okay, let it be silver. I don't bother about that. I don't bother about this. It's a thin lens. Thin lens. So this thickness I have to ignore. This thickness I have to ignore. Now, under what condition I am going to get my image here? It must retrace. I have a reflecting surface here. In what case the light will retrace? This is my object here. This is my object. Object here. Okay? Object. My object here. Light rays start. They hit the first surface here. They hit the first surface here. They will enter into the lens. Then they will hit this mirror. I want my light rays to come back at the same point. I want them to retrace from a plane mirror. Under what condition they will retrace? If they are incident normally like this. This angle is 90 degrees. Okay? That means the first surface should form its image where? From the first surface, image should be formed where? Such that the light becomes parallel to the principal axis. The image must be at infinity. Okay. First image from curved surface must be at infinity. Now, what is the formula relation for reflection from curved surface? I have this. Okay, mu2 over b minus mu1 over u is mu2 minus mu1 over r. I want my image from this surface to be at infinity. That's how it will become parallel to this principal axis and it will hit the mirror normally. Then this light ray is going to retrace. And whenever the light retraces, it retraces its complete path. From wherever it started, it is going to reach back to that point. Okay, so that's how I will get my final image coinciding with the object. Okay, are you able to follow all of this? Okay, let's see. That's how my final image will coincide. Okay, with the object. So now this is mu2, it is given already. 1.5, so this is 1 here, this is mu is 1 here, and here the lens medium is 1.5, so 1.5 over infinity minus 1 over u, okay, is equal to 1.5 minus 1 over radius, 20 centimeters. It is positive, okay, so for this surface, okay, this is my sign convention here, it becomes plus 40. Well, plus 20. So this becomes 1 over 40. 0.5 here, okay? So u becomes minus 40 centimeter. This is one way of doing it. This is one way, first method of doing it. Now there is one other way. There is one other way of doing the same thing. Try to understand that also. I can think of this as a plano-convex mirror plus this plane mirror. Plano-convex lens. Try to understand this. I can think of this as a convex mirror in contact with a plane mirror. What will be focal length of this mirror, this lens? 1 over f is mu relative minus 1 over R1 minus 1 over R2. Okay. So focal length of this 1 over f is 1.5 minus 1 over plus 20 minus 1 over infinity. This is a plane surface here. Okay. This is 0.5 times 1 over 20. This focal length becomes plus 40 centimeter. Now, I want my image at infinity. I want my image at infinity. I have a lens. I have a convex lens. This also is a convex lens. Do not be confused about this plane surface. Does not matter. I have a converging lens. This is focal length. Focal length is plus 40. Okay. I can have a converging lens like this also. Do you understand this? Okay. Do not bother about the shape. Bother about this. It is positive, that means it is converging. That's it. I have this converging lens. I have one object here. I want its image to be at infinity. Where should I keep it? Obviously, I should keep it at its focus. If the object is at focus, the image is at infinity. That means if I keep my object here at the focus of this lens, what is the focus of this lens? 40 centimeter. Then the image will be at infinity. This will create an image at infinity. Okay, and it will the rays will fall normally on this mirror. Okay, it's like this. Okay, so this is 40 centimeter. That means if I keep my object at 40 centimeter, this object is 40 centimeter at the focus. So after diffraction, they are going to go like this. And if I have a plane mirror here, it is going to be reflected. Light rays are going to reach back to the object. That's how I get my final image coinciding with the object. Can you apply both methods to solve this problem? Can you do that? Can you do that? Let's see. First image from curved surface must be at infinity. Is that right? No, that is not right. Why it is not right? I want my light to retrace. Okay? So I have this surface here. This is a concave mirror. Under what condition the light ray is going to retrace? It can retrace only if they appear to be coming from its center. If the light rays to this mirror, if the light rays appear to be coming from its center, okay, then it is going to retrace. Okay, the light rays are going to retrace here. Okay, and this is my surface here. Okay, this distance here from here to here, it should be equal to R, is 20 centimeter. For both surfaces, it is 20. Okay, so from the first surface here, I do not know where the object is. Let me say that my object is here. Let's say that this is my object. So from the object, light rays will start like this. From the object. Okay. After refraction, when they enter the lens, this medium, and hit the mirror, this mirror, this light ray should appear to be coming from its center. Okay, then it will retrace it. Then these light rays fall normally on the mirror. They will fall normally when they appear to be passing from center here. Okay, in that case, this mirror will retrace, send back, retrace the light ray. And whenever light ray retraces, it retraces its complete path. Okay, so it will not reach here. It will reach here from wherever it started. So I will get my final image here. Okay. So first image should be first image from curved surface should be at center of mirror. Okay, that means V is equal to minus 20 centimeter. Now I will write this relation, mu2 over V minus mu1 over U, mu2 minus mu1 over R. Okay, this is 1.5 over minus 20. Okay, minus 1 over U I want to find out. So whatever I want to find out, I will not write plus and minus. I do not know what it is going to be. I will simply write U, that is unknown variable. Positive, negative sign, it is automatically going to, okay, we are going to get it automatically. This is 1.5 minus 1 over, this is a plus 20 here. For this surface, the sign convention is this, positive and negative. Okay, so I get this thing, this is 1 over 40. Okay, you see, so 1 over, so this becomes 3, so minus 3 over 40 minus 1 over U is 1 over 40. So 1 over U is minus 3 over 40 minus 1 over 40. U becomes minus 10 centimeter. That means this distance here should be 10 centimeter. Okay, it should be 10. You can also do it by finding its focal length. Okay. You can also do it if you consider this to be a lens plus a mirror. What will be its focal length? 1 over f is 1.5, 1 over. Okay. First surface, second surface, both are 20 centimeter. For the first surface, okay, this will be my sign convention, positive and negative. It is plus 20 minus 1 over minus 20. Okay, this is 0.5 times, this becomes 2 over 20. Focal length becomes plus 20 centimeter. V is equal to minus 20 centimeter. Okay, I want my image here. I want my image at the center of the mirror. Okay, so I want my image here on this side. V is minus 20. What is U? U is 1 over F plus 1 over U. 1 over V. 1 over V. No, but I want to find U. I want to find 1 over U is equal to 1 over, what it is? 1 over V minus 1 over F. Is that right? Is that right? I think it's right. Okay. 1 over U. So 1 over minus 20 minus 1 over plus 20 minus 2 over 20. What is U? Minus 10 centimeter. Same answer. Okay. Try to understand both methods. Try to understand both methods. And okay, give it some time. Try to absorb it. Try to internalize it. Very, very important. Okay. And now what we are going to do is a very important method. It is not only important, it is actually an experimental technique, an experimental method to find focal length of a convex lens. There are many methods, many experimental methods for finding focal length of a convex lens, but one method is very, very important, and it's a beautiful method. Okay, beautiful method. It is known as a displacement method. It is known as a displacement method. Displacement method. Okay, for finding focal length focal length of a convex, okay, convex converging lens. It's like this. Let's see how it works. Okay. Let's see how it works. Understand the method. I have this object. Object is O. Okay, it is fixed. And I have this screen. This also is fixed. Okay. Sorry. I have this object. Object is fixed. The screen is fixed. I have a convex lens, converging lens. Okay. So I bring in this converging lens and I start moving the converging lens between the object and the screen. Okay. At one particular position, I am going to get an image. That is always going to happen. Convex mirror forms a real image. Okay. So at some particular position, let's say that at this position here, I get a real image. Okay. A sharp real image. Okay. At this position here. This is my image. Okay. Now this distance is, let's say that this distance is d1. The distance between object and the screen, it is capital D here. Okay. Object, image, convex lens. Now, reciprocity. Object and image can be interchanged. That means object distance and image distance can also be interchanged. This is the object distance now. This is the object distance now. Okay. And this is the image distance. And they can be interchanged. That means if I keep on moving this lens, then at a certain position I am again going to find image at the screen. It is always going to happen. Okay? Let's say that this position is D2. So what is happening? Okay, I am getting a real image on the screen for two different positions of lens. This is known as displacement method. And if I know these values, okay, if I know this thing, the separation between these two positions, okay, so I am going to get a sharp real image on the screen for two different positions of lens. And if I know the separation between these two positions, I can find focal length. Okay? Now, if this is D1, what this should be? What this should be? Should this not always also be D1? Object distance here, image distance. Now, if this becomes object distance, this becomes image distance. Okay? They can be interchanged. So, this is also D1. Okay? And if this is D2, is this also not D2? This must be D2. D1, D2. Object distance, image distance. Object distance, image distance. This is D2. Okay? So this whole thing is D2. Out of that, this is D1. So what is D? Is D2 minus D1. Okay, and what is capital D? Capital D is D2 plus D1. Okay, anyway, if I do some more calculation, I can arrive at the focal length. Okay, I'm leaving that part to you. Okay. I will just write the formula and understand that deriving is not very difficult. It's very super easy. Just write the length formula. Okay, for these two distances. At one time, you take this as object distance, this as image distance. Second time, this as object distance, this as the image distance. Okay, and using these conditions, you are going to get formula. Okay, but what we are going to do now is actually not using the formula. We are going to solve a problem without using formula. We are going to solve a problem without using formula. Okay, let's see how the problems are asked. An object and a screen are fixed at a separation of 90 centimeters, and a convex lens is moved between them. Okay, a sharp image is obtained on screen for two different positions of the lens separated by 30 centimeters. Okay, find focal length of lens. That's how questions are asked. They will never mention that it is a displacement method. That is something that you will have to figure out. Read the problem and then correlate with this. Is this not a problem of displacement method? Yes, it is. It is. You can solve it without using formula or using formula. Let's do it first. Let's do it without formula. Try to solve it. Okay. I'm going to give you an answer. Do you know what is the answer? Answer is 20 centimeters. Now try solving it. We are going to solve it here. In this class itself, we are going to solve it right now. Okay? Forget about this displacement method. Forget about the formula. Let's first try to understand the problem. It's like this. I have an object and a screen. I have an object here and my screen is here. Both are fixed. This distance from here to here is 90 centimeters. 90 centimeters. Okay. Now, I am moving lens between them. A lens is moved between them. A sharp image is obtained on screen for two different positions of lens. Okay. So let's say that in one case the lens was here and I got one image here on the screen. Okay, a real image, of course it is, because on a screen I can get only a real image, not the virtual. And here also I am getting this image. So for both positions I am getting this image. And this distance here is 30 centimeters. 30 centimeters. Only this information is given. How can I find focal length of this lens? Okay, so let's see. Reciprocity. If this is x, let's say, okay, then this also should be x. Object distance here, reciprocity, simple reciprocity. Okay, very interesting. And this is 30 centimeters. Okay, we have the answer right before our eyes. I am going to solve it. Okay, If this is x, this must be x. Reciprocity, simple reciprocity, that's it. Okay. So what I have is 2x plus 30 is equal to 90. What is x? 30 centimeter. 30 centimeter. Now this becomes object distance, and this whole thing becomes image distance. Object distance. Okay, then you look at any one. This is first position, second position. If you take the first position, then object distance becomes 30, image becomes 60. If you look at the second position, then object distance becomes 60, image distance 30. Reciprocity. 1 over f is 1 over v minus 1 over u. This is plus 60. If I take the first position, minus 30. You have the answer. 20 centimeter. Okay, 20 centimeter. You got the answer. Now, there is one other way of doing it, that is formula. Okay, formula. Okay, note down the formula. The formula is like this: F is equal to d square minus small d square over 4 capital D. If you want, you can use this, but it's better to understand this method. Beautiful, simple method, direct method. Okay, involving very many beautiful concepts. But in case it is not working out, okay, for some reason, you can apply this. It is going to give me the same answer. Okay, what is this answer here? It is 60 here. This is 2 plus 1. Okay, so this f becomes plus 20 centimeter. This method works only for a convex lens because object is real. If I use concave lens, diverging lens, I cannot get my image at the screen. The image is always virtual. Okay, it is only for a convex mirror, convex lens, converging lens. Let's use this value. So 90 centimeter. This is d. So this becomes 90 square minus small d. This is small d. Separation between these two positions. Okay, 30 centimeter. So 30 square over 4 and 90, like this here. Okay. So 8100 minus 900 over 4 times 90 here. This becomes 7200 over 4 times 90. 80. This becomes 20 centimeter. Okay, whichever you find easy, understandable, use that.